To work on making more sprite sheets and looking at some ways that we can do that, we're going to go back and revisit Texture Packer online to create the compact sprite sheets as well as the JSON that goes with it, because I think that's easier than using frame numbers. And we certainly could just bring this sprite sheet in like we've done before and designate the frame numbers that we need for our different animations. But I prefer to generate it with frame names and use the JSON from it. So I'm going to take and separate all of this out. And Pascal is a great free tool for doing it. You can use the online version or the downloaded version. So now if I take this image and import it in, and instead of bringing it in as a single image, I can bring it in as a sprite sheet and designate that each one of my frames is 16 by 16, and we can see how that grids it up. So that's going to give us all of the frames that we need. And then I am going to replace this because I don't care that it's open. Now we can see I have all of those frames that are showing up. Now there it is at 1x, so we can see there's the different frames for all of the different characters and monsters. So I'm going to take all of these monsters and turn these, or name them after I export it out. So to get out of here, so I have all individual files, so I can bring them into Texture Packer to write the JSON, I need to export them and then rename the files. So with that, I am going to not download a PNG, which would do a sprite sheet, but instead I'm going to do it as a zip. And it really doesn't matter what the name is because I'm going to be renaming these. So I have to go through and rename. I'm just going to change that to a dash because that's going to fit the naming convention that I want to use. Now when I download this, I'm going to specify where I want this to be. And now in this folder, I want to organize it into my sprites, and I'll put it right here because I know where that is. So that now gives me the export that I need. So going into the export from Pascal, I can see it now generated all of those sprites. So I'm going to rename all of these to fit a specific naming structure that I will be able to reference in my code. And I've taken the liberty of doing that ahead of time. And now when I go here, we'll see I've now named these bat walk down 01, bat walk down 02, bat left, right, up. So we have the bat, the ghost, the skeleton, slime, and spider with all of their appropriate file names. So I have all of those ready to go. And now we're going to take these files and bring these into Texture Packer online, the free version of Texture Packer, because what we can do is we can now have it write a JSON file that's going to then have the correct naming structure. Now, you could make a sprite sheet for each character or each monster, and that would be okay, but the whole point in using a texture atlas is to start putting as many of our different things together as we can so that we only have to load a few assets instead of lots of assets. So going online in the free Texture Packer, I can add sprites. And now I'm going to navigate to that folder. And there's my, so select all of these. So I've selected all of my folders or files, hit open, and it dumps them in. Now we have a few, we can have it pack it however we want. If we pack it up compactly, it's now trying to make it as tight as possible. Now after we've done this, our two options are to download the PNG, download the JSON file, and then we will have access to those in our project. If we need to, if our sprites are really tight in their graphics and go all the way to the edges, we can't always put in padding. We need to appropriately reference that, of course, as we are creating our animation. So I'm going to download the PNG, download the JSON. So I've downloaded these, and now inside of Texture Packer, or inside of VS Code, I moved them into my project folder. They're in the sprites, and we see sprite sheet PNG, sprite sheet JSON. I am going to rename these here, and I will call it monsters PNG and monsters JSON. And when I look at the JSON, we can see the naming structure that we have put into it so that we're able to work with this. So with this JSON and this sprite atlas, we are going to modify the enemy class to accept this information. Now I've also added in an additional file to be used for the player, and it is this unicorn sprite, which is set so each frame is 32, not 16 in size, so I will then scale it down using the set scale command. So I'm going to replace the character now that I intend on using slime as one of my monsters. It doesn't make sense to have that be my player. So we're first going to update that one because that's going to be a quicker update than it will to go ahead and update the monsters. I do want to pull it back up so we can see it's right, left, up, down. That's the order. So this is frame 0, this is frame 4, 8, and 12 because there's 16 total frames. So going back into this, this is now a sprite sheet, not an atlas. We'll do the atlas for the monsters in a moment. So I now can set this at 32. 32. This unicorn, and it's not in assets, it's actually in sprites, which is in the atlas. And it's unicorn 32 is the file. Now we'll be loading in the monsters JSON and atlas in a moment. Well, or we can just do that right now. So it's this.load.atlas. In the atlas, we'll just call this monsters, and it is going to be in my assets, sprites, and then it's monsters.png, and then once again, assets, sprites, monsters.json. So I'm going to leave the existing one there for now. We'll comment it out when we're done using it. We will update the player though and put that in so we can see that taking effect. So the player is not using characters, it's now going to use unicorn, and then I will set scale to 0.5 so it matches what else is there. Now if I save this, we're going to see, it's telling me, oh, did not find monster. So do I type monster? Oh, I forgot the S on monsters. There we go. There's monsters, all right. Or not. Assets, sprites, monsters. Oh, put a slash in front of assets, so it's not done. All right, now assets, sprites. I don't have sprites. Oh, okay. Let's try again. All right, no more red, so now we're in good shape. Now it's telling me we have a texture missing. I can see there is my unicorn. It's waiting to do something, so that's good. But we need to update the player to reflect those frames. So right, left, up, down. So now to update the frames, so right is going to be 0, 3. And left is going to be 4 through 7. Up is going to be 8 through 11. And down will be 12 through 15. Right is 0. Left will be 4. Up will be 8. Down will be 12. So now if we save this, let's see. No error messages, that's good. And now we can see how I now have I can move up, can move down, right, left. Looks like we might need to modify the background color or the unicorn color because we got some artwork that is kind of blending in. So that's okay. These are things that we can fix moving forward. So we've updated the player. Again, this is using just a simple sprite sheet. So I generated this sprite sheet. I just had my frames in Pascal, and then I exported out a PNG sprite sheet, so it created the 4x4 sprite sheet. So there's my unicorn, and then when I load it for the player, which took me way too many tries to get my path names correct. It's a pretty common problem when you see those error messages. When it says can't be found, try and figure out what you're misspelling or type. Now, because it is a 32 by 32 and my game is at 16 for everything else, I did need to scale it down to match. Because if I don't have that, and look here, we'll see how it's now twice as big. Which is, but we can see its purple background or outline is virtually the same as the purple in the game. So I may need to update that when we go into tiled, which is fortunate that we'll be going into tiled to add in some additional items as well. All right, so that's updating the player. Now the player is using frame numbers. It's not using, and now that we're kind of moving into end stages here, I am going to just get rid of these extra ones. We don't need to have multiple things here. So if I have a simple sprite sheet like this, frame numbers works great. But when I have a sprite sheet that looks like this, trying to count out and figure out which frame number I'm referring to for which walk cycle gets a little bit more problematic. And that's why using the JSON file, I'm going to go by name. So I can just reference these frames by their name structure. And we'll just say that's what it's done. So when I look here, we can see previously we just had one type of enemy. So we just, walk left, walk right. So we're going to need to work on appending things, so we'll be passing in type, and then when we pass in the type, so we're setting the type here, we're able to use that value. So when we construct an enemy, we're going to do it just a little bit differently so that it allows us to work with it. So going into the enemies with the type, what we want to do is modify the keys, and then we need to modify the prefix that we're working with to match the JSON. So we want the keys so we can specify, because the key thing to remember is the animations themselves, and this is an optimization we're going to be doing later, is we're going to pull it out of the enemy class, we're going to pull it out of the player class, because the animations themselves don't belong to that class object. They belong to the scene. And because of that, they can be referenced in any class. So the player could say, hey, I want to, when I'm walking left, use the enemy left, or ghost enemy left walk. Or so the animation doesn't belong to the individual, it belongs to the entire scene. Once we make one, the scene has an animation manager that knows all the different animations it can play, and you can put whatever animation you want on whatever sprite is in your scene. It doesn't care. The sprite is just a container, and then that container we populate with whatever animation we choose at any point in time. That's why we can cycle through when we're walking different directions, or when we make these enemy sprites and put them on screen in our game, we're going to be able to put different animations into them. So we need to start making these names match, where it doesn't just say walk down or walk left, it now says bat walk or ghost walk or slime walk. So we'll do that by updating it. And the update is pretty quick. We just go this dot type plus enemy left. And then under the name, as we are here, it's this dot type plus walk left. The numbers remain the same. The zero padding remains the same because if we notice it, the names are 01, 02, 03, so we need that zero pad to be 2 characters long. It ends in PNG because the free version of Texture Packer, the online one, you can't say I don't want suffixes. If you use the paid version of Texture Packer, then or the trial where you're getting the full version, then you can say, yeah, I don't want those, I want to use folders, all of that. Paid one is great, but as we're going to be demonstrating here, you don't have to use it. You can get most of the functionality that you need by using the free one. Now the advantage of the paid one is I could have just taken and put the ghost frames in a folder, the bat frames in a folder. I wouldn't even need to rename them per se. I would just need some numbers. But this way it's going to work. So we spend a little bit of time retyping the names of the files so we can then put this type plus. Now let me copy this. And we're going to then put it on our 4 different animations. So we had it under left, right, up, and finally we will add it to down right here. Then, as we go through, when we're telling the animation to play, we are going to need to tell it, which one we want to play. So that's based on the type. Now this is pretty cool that we can just do this so that the class is going to know which animation it's supposed to be working with for each type of enemy. So we've got this working. Well, I don't know if we have it working or not, but we've added it into our code. Once I save this, you should see a whole bunch of error messages over here because now this isn't going to line up, because now when I save it, it's going to tell me, it's like, I can't read the property frame of undefined. Well, undefined means it's trying to play an animation, but it doesn't know what that is, so we need to go back and define that in our game scene. So when we look at our game scene, so our game scene now has loaded our monsters in the monster JSON, so that's in memory. So let's go find an enemy to work with here. Now if I look at an enemy, instead of calling it Wandering 50, what I could do is I could call the Wandering monster, I will just do Ghost. And then, oh no, that's the Wandering monster. Now this following monster, I am going to set this one as the Slime. But I want to change the atlas that we're using. So I'll change this to monsters, monsters, and monsters. And now let's say these monsters, all these, the whole group of them, we will say, let's do it as skeleton now. Let's see what happens. All right, so got a little something going on here. And it's still unhappy. Oh, and we still need to go, I forgot to keep rescaling the player. Let's just put that back in. So I took it out, forgot to put it back in. All right, so we're having some conversion issues here, and while we're doing this, we're going to troubleshoot where that. So we're specifying the type. Now, when I look here, it's bat-walk-down-01-. Now let's go make sure we're naming things correctly. So if we set it, we passed in bat, okay. So what we're forgetting is that, let's go back to the top here, we need a dash in front of this because we now have the name dash. And dash, dash. And now let's save and see what we get. And we're missing. So it looks like we've must have something off. Got a few animations that are missing, but we can see that now we have the slime, we have the skeleton, and the ghost. So we do have the three that we put up there. And so as we're getting these error messages, we've fixed enemy, but we have to remember that enemy follow also is specifying animations to play. So let's go into enemy follow, since we do have two kinds of enemy behaviors. So we need to specify which animations it's going to be using as well. So now let's save this and see what happens. And now there's no error messages. We have the slime, we have the ghost. So we can run away. We have our different kinds of monsters now showing up. Now if I want to, say, change the skeleton so that the skeleton isn't a skeleton, I could just as easily call this bat. Well, let's try that again. So it's a bat, and this time I can see now I have a swarm of bats along with the ghost and the slime. Now remember the slime, I am tinting it. If I don't want to tint it, turn that off. And on those enemies, they're being tinted as well. Now I'm back to the original sheet colors for those entities. So we can see that the game is starting to come together as we're working on this. So we have different things happening, our different creatures are showing up. So we're making really good progress here that we've been able to update the enemy and enemy follow so that they are now correctly loading from that sprite sheet. So one thing that I want to do here is I want to modify it. So if we notice when we get at a 45-degree angle from the enemy that is following us, it moves in this kind of jiggly line. And what I want to do is add a little time delay so it doesn't just continually alternate between the two. So it will move one direction for about a half second or so, then it will go the other way, and it will go back and forth as it works its way through. So we're going to modify that follow enemy a little bit. So what we want to do is we want to access the time of each update, and then we're going to store a new time value. So then we're going to set this so that we're able to store the time between each update, and only if a certain amount of time has elapsed do we allow it to change its direction. Now if it's far enough away, its direction isn't really going to change if it's farther on one axis versus the other. But when it's at that kind of 45-degree angle from us, it does that little jagged move, and that's just not very appealing. So we're going to try and fix this. So what we're going to do is we are going to store that time. So I'll create a value and call it stored time, set it to 0. And then we need to pass to this update the time value. So when I look at my chasing enemy, which is enemy 2, I'm going to pass to it time. So our main update loop always has access to a time value. So we're going to pass that time value in and save that. Now we go into our following enemy. Following enemy's update is going to receive that value. And then I can say const new time is going to be equal to time. So now we've set that. So what we want to find out is if new time is greater than this dot stored time, then at that point we want to update stored time and we'll set it equal to new time plus 500, or 500 milliseconds, half a second. So when we're chasing, what we want to verify is if half a second has elapsed, then and only then do we want to update our chasing content. So I can take all of that, I've highlighted it, and I can just move it up into that. Move it over so it's properly indented, and now this will be end time delay. So that is now our time delay here, and we can try this out. Now as I do this, what we want to find out is it going to, so when I get here we can see how it doesn't, so it behaves normally when it has more to encounter, but now we can see it zigzags or stair steps instead of doing the little kind of shutter step on its way over to us. So we're using the same delay algorithm that we ended up using with our projectiles. So the projectiles had our last fired time, and we delayed it here for half a second before we could fire again. Now if we find that this 500 is too slow, we could maybe try 300 and see how that behaves. Now when I get here, we can see, maybe 300 is a better amount. So the smaller the number gets, the smaller the stairs are going to become as it hit a wall there. So now it's coming back after us. Oh, hit another wall. Let's see if it finds us. There we go. So now these stairs are smaller. So the smaller this value, the smaller the stair step will be as it follows us. But anything is an improvement over the little shuttering diagonal move that we had previously.